Beat. What is the loudest thing in the universe? The question itself feels almost paradoxical. We're taught from a young age that in space, no one can hear you scream. And for the most part, that's true. The vast, near-perfect vacuum between stars and galaxies is anathema to sound as we know it. Sound is a mechanical wave, a vibration that must travel through a substance, a medium. Here on Earth, we experience it as vibrations passing through air to our eardrums, or through water when we're swimming. Without a medium, there are no molecules to jostle, no pressure to propagate. There is only silence. So, to find the universe's loudest event, we must first find a place in the cosmos that isn't empty. We need to find the medium. Loudness is a measure of the intensity of these pressure waves, typically expressed in decibels. A quiet whisper is around 30 decibels. A rock concert might hit a 120. The threshold of pain for human ears is about 130 decibels. But this scale is logarithmic, meaning that for every 10 decibel increase, the sound intensity multiplies by 10. The push a wave can carry depends on the density of the medium. Sound travels differently through air, water, or solid rock because their molecular structures offer different levels of resistance and transference. The denser the stuff, the more energy a wave can carry, and potentially the louder it can be. On Earth, the undisputed champion of loudness is the 1883 eruption of the Krakatoa volcano. The explosion was so violent it was reportedly heard nearly 5,000 kilometers away. It generated a pressure wave that circled the globe multiple times, registering on barometers worldwide. At a distance of 160 kilometers, the sound was still an ear-shattering 172 decibels, loud enough to rupture the eardrums of sailors on a nearby ship. This is the loudest sound ever definitively recorded in our planet's atmosphere. But Earth is just a tiny stage. To find the true cosmic champion, we must look far beyond our world, to the largest structures in the universe. We find our medium in the immense spaces between galaxies. Galaxy clusters are the most massive gravitationally bound objects known. They are colossal collections of hundreds or thousands of galaxies, all swimming in a vast, diffuse sea of superheated gas. This is the intracluster medium, a tenuous plasma, heated to millions of degrees, so hot that it glows brightly in X-ray light. While this gas is far, far thinner than our air, a near vacuum by earthly standards, it is not empty. It is a substance. And where there is substance, sound can travel. Our search takes us 250 million light-years away, to the heart of the Perseus cluster. Here, at the center of the galaxy Perseus A, resides a supermassive black hole. This cosmic engine is not a silent, passive object. It is an active galactic nucleus, furiously accreting matter and blasting out colossal jets of energy. For billions of years, this black hole has been periodically puffing out immense bubbles of relativistic particles into the surrounding intracluster medium. These eruptions push the gas aside, creating vast, expanding cavities and launching ripples, or pressure waves, through the cluster's plasma. In 2003, astronomers using NASA's Chandra X-ray Observatory detected these ripples. They had found sound waves propagating on a scale almost beyond imagination. The jets erupting from the black hole act like the cones of a cosmic subwoofer, pumping energy into the gas. The cavities they inflate displace quadrillions of solar masses of plasma. The resulting sound waves are low, with a period of nearly 10 million years between crests. This corresponds to a musical note of B-flat, but about 57 octaves below middle C, a frequency trillions of times lower than what human ears can detect. These waves are also enormous, with wavelengths spanning hundreds of thousands of light-years, and they are sustained by the black hole's continuous activity. The sheer energy required to generate them is staggering, equivalent to hundreds of millions of supernova explosions. So, how loud is it? Calculating decibels here is tricky. The gas is so whisper-thin that the amplitude of the pressure wave, the push on any given particle, is minuscule. But loudness isn't just about amplitude. It's about the total acoustic power distributed over a vast area. When you factor in the colossal volume of gas being vibrated and the immense energy carried by these waves, the sound in the Perseus cluster is the most powerful, most energetic, and loudest sustained sound ever discovered in a material medium. It is a deep, resonant hum that has been echoing through the cluster for eons. But what if we expand our definition of sound? What if we consider other kinds of vibrations in the universe? This brings us to another contender, the cataclysmic merger of two black holes or neutron stars. These events are the most violent phenomena we know of. As these ultra-dense objects spiral into each other at near light speed, they don't create pressure waves in a gas. Instead, they violently shake the very fabric of space-time itself, sending out ripples called gravitational waves. These are not sound waves. They do not need a medium to travel. They are vibrations, the medium of space-time. Yet we can hear them. Instruments like LIGO and Virgo detect these minuscule space-time distortions and convert them into an audio signal, a characteristic chirp that rises in frequency as the objects merge. The power radiated as gravitational waves in the final moments of a merger can outshine all the stars in the observable universe combined. In terms of pure energy released as vibrations, this is the undisputed champion. There is one more place we can look for cosmic sound, the very beginning of time. In the first few 100,000 years after the Big Bang, the universe wasn't empty and cold. It was a hot, dense, opaque soup of plasma, photons, and dark matter. Within this primordial fluid, the interplay between gravity pulling matter together and radiation pressure pushing it apart created vast, oscillating pressure waves. These are known as baryon acoustic oscillations. The entire early universe rang like a bell, filled with sound waves on every conceivable scale. The patterns of these ancient sounds are still imprinted on the cosmos today, visible as subtle temperature fluctuations in the cosmic microwave background radiation. Defining their loudness is complex, as it was a feature of the entire universe, but the energy involved was fundamental to shaping the large-scale structure we see today. So, what is the loudest thing in the universe? The answer depends entirely on what we mean by loud and sound. It's a question that forces us to distinguish between different kinds of cosmic vibrations. If we are asking for the loudest literal sound, a pressure wave traveling through a physical medium, then the deep, persistent note echoing through the Perseus cluster, powered by its central black hole, likely wins the title. It is the most powerful acoustic phenomenon we have ever observed. But if we broaden our definition to include any vibration we can convert to audio, then the loudest events are unquestionably the mergers of black holes and neutron stars. The sheer power they release in the form of gravitational waves, warping space-time itself, is unparalleled. The silent vacuum of space is not so silent after all. The universe speaks. It hums in the heart of galaxy clusters, and it chirps with the collision of cosmic titans. It sings in ripples of plasma, and in the very fabric of space-time. We are only just beginning to build the instruments and the understanding required to hear its symphony. We are learning how to listen. Soft. And the night keeps it.